Hello, Sudoku friends, and welcome to a New York Times Hard Sudoku. Today is the 1st of February 2023. I have a little trouble accessing the New York Times website this morning. I don't really know why, but the internet in Vietnam is sometimes weird. Sometimes it's usually called by their firewall and their censorship. So instead, I copied the grid over from my phone, and now I'm solving it or attempting to solve it on sudokuexchange.com. I'm not intending today to try to do a speed run or anything. I want to do a simple walkthrough of how I go about solving this New York Times hard puzzle. I mean, I'm supposed to solve it, but I haven't seen it yet. I just caught up the grid on my phone using 4G. So I'm always looking at shoots. For example, the first three rows, the middle three rows, and the bottom three rows. And I look at them as a whole. And that's how I see that these two sevens block here. And I also immediately see the seven coming down and blocking here. So this has got to be a seven, right? I'm also seeing two eights up here blocking here, making this an 8. And that's about as far as I get from just taking a helicopter view down over the puzzle. The next thing I do is I see, okay, three empty squares. Let's see, what could they be, or what will they be? They have to be a 1, 2, and a 7. So I know that one of these must be a 7 now because the 7 blocks here. And the next thing that I do immediately is looking down here to see if I can find a place for a 7 here. And I can't because a 7 could go here and here. And at this point, I usually have to be a little creative. So what I do is I look at these 5s and 8 and I say, okay, we cannot have any 5 or 8 in these three squares. And we only have two squares left in this row here. And one of them is already taken by an 8, so I will disregard the 8 and I'll just concentrate and focus on the 5 now. It needs to go in one of these two squares, that is without a doubt. And this square is blocked by this 5, therefore this must be a 5. Now I immediately look right and see, okay, I've got two 5s here blocking here. Can I place a 5 up here or not? And I can't because this 5 blocks only this square. So I have two potential candidate squares for 5s in the top row. But the next thing I do is I look down and see which ramifications arise from finding this 5. And all I can see is that one of these must be a 5 now. The next thing I do is I look and see this 5 and this 5 now blocking. So now one of these three cells must be a 5. Now I look at the ones here. They block over here, right? So one of these must be a 1. And since therefore a 1 can't go here or here, I still need to find a 1 for this center column. So a 1 will have to go here or here. So the next thing I now would usually do is I will count what is missing these 4 cells. A 1, 2, 4, and a 9 are missing, right? A 1, 2, 4, and a 9. We have a 1, 4 here, so this is a 2 or a 9. We know that the 1 will have to go up here. We have a 2 and a 9 here, so this cannot be a 2 or a 9. And it doesn't really give me anything. But the next thing I do is I look at these 3, 8, and 5, and I say I need to find squares for the 3, 8, and 5 in these 4 cells. We already have a 3, 8, and a 5 blocking this square. So now I know that these 3 cells here must be a combination of a 3, 8, and a 5. And since I can't place them, I then immediately look at the 3 remaining squares and say, okay, if I've got a 3, 5, and an 8 here, what's missing? Missing is a 1, 2, and a 7. And I can't place any of those 3 in these cells. What I then do is I say, okay, I know that these have to be a 3, 5, and an 8. What about these 4 or 5 squares here? What must they then be? We know that the 4 blocks here, so one of these must be a 4. And we have got a 1 coming over here. We got a 1 coming over here. And they can't go in any of these. We cannot have a 1 in any of these 3 squares, right? So that means that this must be a 1. And this way I've now found a 1 for this square. And now I know that these have to be a 2 and a 7. And I also know that these have to be a 2 or a 7, no, a 2 and a 7, and we have a 7 in this row, so this must be a 2 and this must be a 7. And now the 7 here and the 7 here, of course, gives me a 7 here or here. And we have a 7 blocking this square. So where now can we place a 7 in this row 3? It can't go here or here because of these two 7s, so it must go here. So we are slowly filling in the digits that appear logical, because each time we enter a digit, we reduce the number of possible candidates for the row and the block and the column. So a 2 and a 7 here, that still leaves a 1, 4, and a 9 for these, right? So we got a 1 here, so this is a 4 or a 9. We know that one of these must be a 4 because we got a 4 blocking down here and we got the 4 blocking over here, right? So one of these is a 4 and therefore one of these must be a 4. We also know that this can't be a 3. So a 3 will have to go here or here, and we have a 3 up here too. So one of these must be a 3. So we're getting back for a moment to the 3, 5, and an 8 here. We are left with a 4 going over here in one of these two squares. But now look at the 6. The 6 blocks here, right? And this 6 blocks down here. These are taken by the 3, 5, 8. So we only have one square left for 6, and that's here. And that makes this automatically a 4, doesn't it? And that means that this must be a 4 now, because that's the only available square for a 4 in this row. And this now must be a 9 because it's the last digit that we need. So these being a 3, 5, and an 8, that leaves only one empty square for the 2. And we still have the 2 and the 7 here, making this a 1 and a 9. We have a 9 in this row, making this a 1 and this a 9. Now one of these must be a 1, because we have a 1 coming up blocking here, we have a 1 coming over blocking here. So one of these must be a 1. We also have a 1 already in row 3. Where now can we place a 1 in row 2? It needs to go here or here, but the 1 here blocks this square, so this must be a 1. And now this 1 blocks down here, this blocks up here, this one blocks this square, making this a 1. These two empty squares now I need to be a 3 and a 4, and I can't do much about them now, but I can place a 3 here because this 3 blocks all these 3 squares, making this the only square available in this block that can be a 3. Now the 3 here and the 3 here block down here, right? Making this a 3. I still can't place the 3, 5, and an 8 here, but I feel that I'm closing in on them. These 3 empty squares must be a 4, 7, and a 5, and I can't place them. What I can do, though, is extrapolating and saying, well, if one of these is a 7, then this here can't be a 7, therefore it must be a 2, and this must be a 7, right? And we know now that this must be a 2. And since these are 3 and 4, these must be a 1, 6, and a 9. And I can't place them yet. But I feel that we are getting closer. These 3 squares have to be a 3, 5, and an 8. Look at, look at this. We had a 3, 5, and 8 coming down here, 3, 5, and 8 missing over here. We have a 3 and a 5 observing this square here. So this must be the 8, right? So this can't be an 8 now. This is a 3, 5, and this is a 3, 5. These 3 squares must be a 2, 4, and a 9. We have a 9 in this column, therefore this must be a 9, and this is now a 2, 4. We have a 4 very conveniently in this row, so this is a 2 and this is a 4. What's missing here? A 4 and a 5. We have a 5 in the row, so that's pretty easy, isn't it? The 4 goes here and the 5 here. These now have to be a 4 and a 7. We have a 4 in the column, so the 7 goes here, of course, and the 4 here. Now we remember that these two 7s gave us a 7 candidate in these 2 squares. We have a 7 now bearing down on this, therefore this must be the 7. What can go here? A 2 and a 9. We have a 2 in the row, making this a 9 and this a 2. And these 3 empty squares now must be a 5, 6, and an 8. There's an 8 and a 6 in this row, so this gets to be a 5. And while I'm remembering it, the 5 here and the 5 here blocking over here, and the 5 blocking down here, so this is, of course, a 5. And I might as well fill in this 5 as well, making this a 3. Now these have to be a 5, 8. There's a 5 here, so the 8 goes here and the 5 here. Now we got 1, 8 here, here, and here, and that makes this an 8. I know I should have continued with these two, but this just was so easy, wasn't it? The 8 coming up here and the 8 coming down here, the 8 coming over here. This is an 8, and that makes this an 8, and this has got to be a 6. These two 6s block here, don't they? Making this a 6. And what's going here? A 9. And we got a 9 coming over here, the 9 coming up here, making this a 9, and therefore this must be a 9. And we really are closing in on the solution here. We have got a 3, 4 here and a 1, 6 here. We got a 6 already in this column. Therefore, this is a 1 and this is a 6, making this a 6. We don't need any counting. We can just look at the empty squares and we know where things go now. This is a 2 and a 3. And this is also a 2 or a 3, but we have a 3 already. Very convenient in this row. So this is a 2, making this a 3, making this a 2. And this square must be a 3 now, and we now have a 3 here and here. That makes this a 3, and the last digit was a 4. Remember, this is also a 4, and this has got to be a 1. This was a rather long-winded puzzle, but I thought I would just do a thorough walkthrough and share how I solve puzzles like this. It was a New York Times hard puzzle, which means that it's usually not that difficult. Of course, you can always use pencil marks, but once you get a hang of it, it gets really, really simple to solve these New York Times puzzles. I hope that you enjoyed it, and I thank you for watching, and I welcome you back for more soon. Goodbye for now.